Jai Hind everyone, I am Dr. Ekta Pandey. I am an assistant professor in the Department of Mathematics in Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to discuss the topic Test of Significance by T-Test from Module 5 Statistical Technique 3rd from the course Mathematics 4. So let us start. Before discussing about the test of significance, we should discuss some statistical terms. The first one is population. See, generally in statistics we are interested in the analysis of the group of individual on the basis of some of its characteristic. This group of individual is known as population. For example, if we want to test the quality of a product produced by a factory, then the whole of its production will make a population. Similarly, if we want to study the average marks of a college, then the marks of each and every student of the college will make a population. Okay. Now see, next term is sample. Next term is sample. See, it will be difficult to study the population as it may contain large number of items. So instead of study a population, what we do, we will take a subset of the population. For example, a population with 100 items. From the population of 100 items, we can take a subset of 10 items. This subset is known as sample. Now it will be easy to study a sample because it contains less number of items. See, for example, we can test the food is well cooked or not by taking a spoon of it instead of eating entire food. Similarly, we can test the production of a factory by taking a sample of it instead of testing each and every unit of the production. Now, next term is parameter. For a population, we can find some statistical constant such as mean, median, mode, variance, skewness, kurtosis, movements, etc. These statistical constants are known as parameter. Similarly, these constants can also be obtained for the samples observation, but now these constants are known as statistic. So, if we are finding the statistical constant for population, then we call it as parameter, and if we are going to find these constant for sample, then we call it as statistics. Now see, you can observe a difference between sample statistic and the population parameter, but it should not be there because we are taking a sample from the population. Then there should be no difference between the statistic and the parameter, but somehow you may observe a difference between the sample statistic and the population parameter. Now the next thing is, that we should do is we will test the significance of the difference arise between the sample statistic and population parameter. We will observe how much this difference is significant. We will observe how much. Okay, this is known as test of significance. Okay, so if we apply a test of significance, then we can test the significance of the difference between the sample statistic and the population parameter. And see, if the difference is not significant, then this implies the properties shown by the sample. Properties shown by the sample can be assumed for the population also. And if the difference is significant, then this implies the properties shown by the sample cannot be assumed for the population. Now, there are various tests to test the significance of difference between the sample statistic and population parameter. These are t-test, f-test, ANOVA. There are many more tests are there in this statistic. So, for the particular problem, we pick a particular test. Now, I am going to discuss the procedure of the test of significance. Now, the first step is to set a null hypothesis. Null hypothesis is just a statement of no difference. It assumes that there is no difference, or you can say not a significant difference between the samples statistic and population parameter, and it is denoted by H0. Next step is to set an alternative hypothesis. Alternative hypothesis is just the opposite of the null hypothesis. and it is denoted by H1. Opposite means here it will assume that there is a significant difference between the sample parameters, sample statistic and population parameter. Now next step is to find a suitable test statistic. I have told you we have many tests, t-test, f-test, ANOVA, but for a particular problem we apply a particular test. So the next step is to find the suitable test statistic. For example, in this session we will discuss about the problem in which we can apply the t-test. Next we will find the value of this test statistic by using the observation obtained by sample and the value of the claimed value of the population or the value obtained for the population. Next, we will find the critical value of the test statistic we choose, like for t-test or f-test or ANOVA, we will find a critical value. We find this value at 5% level of significance and some specified degree of freedom. We can find this critical value from the standard table of the particular test statistic. For example, we have a standard table for t-test, for f-test also and for ANOVA also. So we can find the critical value from the standard table. Now here we can see three important words. The first one is critical value, next level of significance, LOS stands for level of significance, and then DOF means degree of freedom. In the next slide we will discuss about these three terms. Okay. Here in this slide we can focus only on the procedure. Now the last step is to take a decision. How to take decision? Here we will compare the value of test statistic with the critical value of the test statistic. Now see, when we compare the value of test statistic obtained in the third step, we take only magnitude. There is no significance of plus or minus sign. What will we take? Only magnitude. So we have taken modulus here. This one is modulus. So we will take modulus, means magnitude of the calculated value. We call it as calculated value. The value we obtained in the third step using the observations of samples and population. And we will compare it with the critical value. If calculated value is less than the critical value, then we accept the null hypothesis. And what is the meaning of accepting the null hypothesis? It means we assume that there is no significant difference between the sample statistic and population parameter. And it means, what does it mean? It means the property shown by sample can be assumed for the population also. Now see, if calculated value is greater than critical value, then we will reject the null hypothesis. And what does it mean? If we reject the null hypothesis, then it means there is a significant difference between the sample statistic and population parameter. And if there is a significant difference, then it means we cannot assume the properties shown by the sample for the population. Okay. So these are the steps to apply the test of significance. Next. Now we will discuss the three terms we saw in the last slide: level of significance, degree of freedom and the critical value. See, level of significance. On the basis of test, we can take a decision of rejecting the hypothesis or accepting the hypothesis. Okay, but sometime it may happen that we reject the null hypothesis when it is true. We can commit this type of error by applying the test of significance. So this chance of rejecting a null hypothesis when it is true is known as probability of taking wrong decision, which is known as level of significance. So basically, what is level of significance? Level of significance is the probability of taking wrong decision. Which wrong decision? I am talking about a particular wrong decision, and the decision is rejection of null hypothesis when it is true. Okay, so while applying the test, we keep this probability of taking wrong decision in parallel, and it is denoted by alpha. And this probability is fixed in advance before collection of the sample information or before applying the test. And because it is fixed, it can be taken as 5% or 1%. Usually it is taken as 5% or 1%. You can take 10% also or 20%. but the most reliable values are 5% or 1%. Now, if we take 5% level of significance, this implies, what does it mean? It implies that we are 95% confident of our decision of rejecting the null hypothesis when it may be true. Okay, so this is known as level of significance. You can just remember that probability of taking wrong decision is known as level of significance. So, when we apply the test of significance, we may have a wrong decision, and the probability of having this wrong decision is taken as level of significance 5%. Next term is degree of freedom. Now we will talk about the degree of freedom. Critical value depends on the two things, level of significance, and the next thing is degree of freedom. So what is degree of freedom? Degree of freedom is number of independent observation used in making a test statistic. Here I will tell you a formula for a particular test. That formula I am calling as test statistic. We will discuss it in the coming slide. This formula, the formula of the test statistic, will be discussed later. So, when we pick a test statistic, then then the value of this test statistic depends on the observation of samples. Now, the number of independent observation used in making the test statistic is known as degree of freedom. Okay, means independent means which have the freedom to vary, means these observation can be varied in the value. Okay, and it is calculated as, the calculation means how can we find the number of independent observation? Total number of observation we are using to find the statistic minus number of different parameter. This is a formula to find the degree of freedom. See, by we can understand it by an example. For example, we have a population and it contains various number. Now, what I have to do, we are taking a sample and I am going to take only 3 number from this population. These 3 number, I have to take these 3 number such that there is a condition such that the mean of these 3 number is equal to 34. The mean is equal to 34. Then from this population, we can take any 2 number. We can take any 2 number. But when we are going to take third one, then we are not free to take any number. We have to take only that number for which the average of these 3 number should be 34. Okay, so now you can see the number of independent observation. How many observation will be independent? Number of independent observation will be number of total observation 3 minus number of different parameter. Parameter means the statistical constant. What I am going to calculate? Just mean, only mean, one parameter. So 3 minus 1 is equal to 2. So degree of freedom will be 3 minus 1 is equal to 2. Because I am finding only one statistical constant, which is mean, for one sample only. So number of different parameter is equal to 1, only 1. So degree of freedom will be equal to total number of observation minus number of different parameter, that is 3 minus 1 is equal to 2. Next term is critical value. What is critical value? Critical value is the minimum value for the test statistic to reject the null hypothesis. This is clear from the definition of the decision. Here we accept the null hypothesis when calculated value of the test statistic is less than the critical value, and beyond that we will reject the null hypothesis. So from this definition you can understand that the critical value is the minimum value to reject the null hypothesis. See, this one is the critical value. Okay, and if the calculated value is less than the critical value, then we accept the null hypothesis, and when it is greater than the critical value, then we will reject the null hypothesis. So you can see from this line that critical value is the minimum value to reject the null hypothesis. Now this critical value depends on level of significance and degree of freedom and can be obtained by the standard table of the distribution. See, this one. This is the standard table for the T distribution, and you can find the critical value from this table. We will learn how to read this table from the example. Okay, now let us start the test of significance, and here from various tests of significance I am going to discuss the T test. Okay, so T test, when we apply the T test is used when the sample size is less than 30, means in our sample maximum number of item can be 30 only then we apply the T test. So let us see where we can use T test and how can we use the T test. T test is used to find the significance of the mean, significance of the difference of the mean of the sample and mean of the population How can we use the T test? T test is used to test the significance of difference between the mean of sample drawn from a normal population, and this mean is denoted by x bar. The mean of sample is denoted by x bar, and the mean of population is denoted by mu. So what will it do? It will test the significance of difference between the sample mean and the population mean. This population mean will be given, or you can say in statistical term it will be stated or claimed. For example, for my class, maybe I can claim that the average marks will be 70. So my whole class will be a population, and the stated value or the mean of that population that I am claiming is 70. Okay, so population mean generally will be a stated or claimed value. Or you can say, you can take one more example. For example, if I am manufacturing bulb in my factory, and then I can claim that the average life of the bulb will be at least 4 years or 3 years, anything like that. So generally the mean of population will be a stated or claimed value. Now we will test this claimed value by taking a sample from the population. For example, I can take 10 students from my class and I can take their test. Now I can find the average of these 10 students and can compare them from my claimed average. I have claimed that 70 will be the average. Okay, so from the average marks of 10 students, I can compare the average marks of the population, and now can take a decision whether or not I am right. Okay, now the working procedure, I am going to apply the test. For this type of problem, when we are comparing the mean of sample and population, we always apply T test. Now this step 1, there is no significant. First of all, we will set a null hypothesis, and null hypothesis is the statement of no difference, means no significant difference between the sample mean and the population mean. Or you can say claimed value. Population claimed value is true. Here is the claimed value. Statistically, what we write, the claimed value is true. Means I have claimed that average marks of my class will be 70. Then what will I got? The average marks of 10 students that I have taken as sample will also be 70. So in first step, we define H0 means null hypothesis. Null hypothesis means sample mean and population mean will be almost same, and it means the claimed value of the population mean will be true. In second step, what we will do, we will define alternative hypothesis. What is alternative hypothesis? It is just opposite of null hypothesis, and what will it say? There is a significant difference between the sample mean and population mean. Means sample mean and population means are significantly different, and this implies statistically what can we write it? Mu is not equal to claimed value, means I was claiming that the average of my class will be 70, but it is wrong. It may happen that average marks may not be 70. It may deviate significantly from the 70. Now step third, we will apply t-test. Now here I will tell you about the test statistic, this step. Suitable test statistic, we have obtained the suitable test statistic. Which one? T-test. To compare the mean of sample and population, we will always apply t-test. Now we will find its value. Its value is obtained by a formula. I am going to discuss this formula. For each and every test, there is a formula to find the test statistic, and here the test statistic is defined by this formula. Please, you can note this in your copy. And the formula is defined as the difference between the population sample mean, population mean upon capital S divided by root n. So n, so you can know, is a number of item in the sample. Please note, it is a number of item in the sample, or you can say it as sample size. And this one is S. S, what is S? Actually, S stands for standard deviation. But we need a standard deviation of population. We don't need the standard deviation of sample. We need the standard deviation of population. So, but we don't have the standard deviation of the population, and it may be impossible to find that. Why? Because the population may contain large number of items. So we will find the standard deviation of the population using the sample observation. See, we have a sample. It may contain 10 items, x1, x2, x3, x4, x5, x6, x7 and so on. 10, 12, 30, up to 30 we can easily obtain the standard deviation. But we are going to make a simple small change that you should note here. Capital S is the estimate of population, standard deviation obtained from the sample observation. See, if we are going to find the standard deviation of the population from the sample, then what we do, we apply this formula, root of summation x minus x bar raised to the power 2 upon n minus 1. What is the difference? If you can remember the formula of standard deviation, we divide this sum by n. Remembered? If we divide this sum by n, then it is known as standard deviation. But here I am dividing this sum by n minus 1. If we divide this sum by n minus 1, so approximately it will provide the standard deviation of population. But if we divide this sum by the sample size, means n, then it will give the standard deviation of the sample. In statistics, there is a theorem that this result will approximately give the standard deviation of population. So here what you need, just learn the formula. Now next, or now if you want to use sample standard deviation, then what will you do? Here in the t statistic, there is a small change again. Just divide the difference x bar minus mu with small s divided by, now instead of dividing by root n, we will divide it by root n minus 1. Why? Because the standard deviation of the sample, this formula is taken. Now compare these two formula. If you can compare these two formula, you can easily observe that capital S square will be equal to n upon n minus 1 s square. And this implies s upon root n will be equal to small s upon root n minus 1. Okay, so instead of s upon root n, we will take small s upon root n minus 1 if we want to use the sample standard deviation. Now next step is to find the critical value of the test statistic. Usually we take 5% level of significance, and the degree of freedom for the t-test is n minus 1. Why? Because here from the sample we are calculating only mean, only one parameter. Statistic, for sample you can call it as a statistic, and for population we called it as parameter. So for from the sample we are just calculating only one thing, which is called as mean, which is mean or total number of observation is n, so degree of freedom will be n minus 1. Okay, now from the table we can find the critical value, and the next step is the taking of decision. Now we will compare the critical value and calculated value. If calculated value is less than the critical value, then null hypothesis will be accepted, otherwise we will reject it. So this is the procedure of applying the t-test. You should write this formula. So please note it. If you are using population standard deviation, then divide capital S by root n. If you are using sample observation, sample standard deviation, then divide small s by root n minus 1. Then both will give the same answer. Both will give the same answer. Okay, now let us take an example. The lifetime of an electric bulb for a random sample of 10 from a large consignment gave the following data. Here from a production or lot, it has taken 10 item. 10 item means we have a sample with size 10, and it is noting the average life. For first bulb, average life is 4.2, for second 4.6, and so on. Now next is, it is taking the square of the deviation of each item from the mean. Okay, so mean, how can you find the mean? The formula of finding the mean is summation x upon n, sum of all the values upon number of item, or it is coming as 4.4. 4.4. So here we have x minus 4.4 raised to the power 2 also. So this is the table given in the problem. Now see, can we accept the manufacturer claim that the average lifetime of the bulb is 4 hours? Average lifetime of the bulb is 4 hours. Manufacturer is claiming that the average life of the bulb is 4 hours. Now we have to test his claim by using t-test. Why? Because it is talking about the average. When we talk about the average, then average can be compared by using t-test. Now first of all we will define a null hypothesis. And what is null hypothesis? We will take there is no significant difference in the sample mean and the population mean. Means if we test a sample, then it will come that the lifetime of the bulb is 4 hours. So here we assume that the claimed value will be true. We assume that the claimed value will be true. Mu will be 4 hours. Next one is alternative hypothesis. Alternative hypothesis is just opposite of this, and so we write it as the claimed value will not be equal to 4. And see, we call it as two-tailed test. Why? Because mu less than 4 can be any value. Mu can be less than 4 or mu can be greater than 4. In this problem, it is not specified that we have to test it for left side or right side. Means average may come out less than claimed value, or average may come out greater than the claimed value. It can be any one of these two cases. So this is known as two-tailed test. Now we will define a test statistic. This is our formula of finding the test statistic. X bar minus mu upon capital S divided by root n. Capital S means population standard deviation was given by root of sum of square of deviation of the item from the mean upon n minus 1. Now see, due to this formula we have to calculate this row x minus x bar raised to the power 2. Now you can understand it was already given in the table, and if it is not given, then you have to calculate this row. Okay, so to find this value, first of all we have to find the mean, which is equal to 4.4. Then find the deviation of each item from the mean, then take its square, and we have all these values. Now just what you have to do, find its sum, and its sum will be x minus x bar raised to the power 2. And okay, this sum is coming out as 3.12. This sum is equal to 3.12. So you can easily find out population standard deviation. It will be equal to 3.12 upon n minus 1. Here we have 10 items now. So 10 minus 1 is equal to 9. So capital S will be equal to root of 3.12 upon 10 minus 1, 9, and it will be equal to 0.589. So first of all, you will find its population, standard deviation means capital S. Now put the value of S, sample mean and population mean, capital S, and sample size in the t-test statistic formula. Okay, so our t-test statistic will be, I can write it here, t will be equal to x bar. Our mean of the sample was coming out as 4.4. So put 4.4 minus population mean was 4 divided by capital S was 0.589 divided by root n means 9. Now calculate this value, and this value is coming out as 2.123, this one. So we have calculated the value of t. Okay, so now the next step is, the next step we have to find the critical value of the t statistic at 5% level of significance is default, and the degree of freedom for t-test, degree of freedom is defined by n minus 1, which will be equal to 9, as the number of item in the sample was 10. And from the table we will find this value. Now we will learn how to read the table. This is our table to find the critical value of the t-test, and you can see here 2 dimension. This dimension, this one, the horizontal dimension represent the level of significance, and this vertical dimension represent the degree of freedom. Okay, now we have degree of freedom 9 and level of significance is 5%, means how much probability? 0.05. And the test that we are applying is two-tailed. So you will find the critical value using this row, second row. There are 2 rows now, 1 and 2. You will go in the second row where you can see two-tail. So 0.05, this one is 0.05. Now come down in this direction and go in the rightwards direction. Then here, where these 2 directions cross each other, is 2.262. So the critical value is 2.262. Okay, so 2.262 is the critical value. Now the next step is to take decision. How can we take the decision? We can take the decision by comparing the calculated value with critical value, and you know, we have to take only magnitude. So what was our calculated value? It is 2.123. So here 2.123 will be compared by 2.26, and you can see it is less than, calculated value is less than 2.26. This implies your decision is accept the null hypothesis. Now if you are accepting the null hypothesis, this implies there is no significant difference between the sample observation and the population observation. Okay, and this implies the claim of the manufacturer is true. This is our decision, and this is the solution of the given problem. I hope you understood it. So that's about all about the t-test. Now in coming section we may discuss more about the test of significance. Thank you for watching the lecture.